We are in the launch of We Are in AI. I want to give a big shout out to everyone that spent the time on a weekend. You could spend it somewhere else, but you decided to come and learn with us and see how you can shape a more responsible future for AI. Kudos to you. This event is for educational purposes only. While we aim to inspire and educate, we will also ask you to do your own research and then make up your conclusions. Tell you a little bit about We Are in AI. We're building the largest network for responsible AI and human-centric innovation. We believe that we are an intersection of responsibility and possibility, and it's up to all of us to build a more sustainable future. That's why we created the organization, because we want to put diverse voices together to shape the future of AI. And without further ado, I'm going to introduce our first speaker for this morning, Shlomo Dubnov. He is a professor in the Music and Computer Science Department and founding member of the Data Science Institute at the University of California, San Diego. He's a graduate of the Rubin Music Academy and holds a PhD in computer science. He serves as a researcher at the world-renowned Institute for Research and Coordination in Acoustics in Paris and was visiting professor at Keio University in Japan, the University of Bordeaux in France, and Richmond University. His research of statistical modeling of music style led the development of the field machine improvisation. Currently, he serves as a director of the Center for Research and Entertainment and Learning at the UCSD Qualcomm Institute and teaches interdisciplinary computing and arts program.
First of all, thank you so much, Gerard, for hosting and organizing and inviting. And thank you, everyone, for coming on the weekend. Hi, everyone. So my introduction for the morning, I hope, will be entertaining and also enlightening in a way of introducing the work that we are doing in UCSD, also with a lot of colleagues across the world, but also I think which is very relevant to the future of AI. And I'm very much interested, of course, in the arts as a musician, in AI as a computer science researcher, but also in the cultural aspects. So just a few words about me. I come from San Diego, and on our top left, we have the music department, and actually the book that is just next to it, you can see on the cover our great music concert hall, where the acoustics and the whole design is very, I would say, technical, acoustically and modern, one of the, I would say, best places to perform music besides other facilities in the music department. One is the Qualcomm Institute, or CALIT2, which is the California Institute for Technology, Information Technology. Next to it is the Computer Science building. I'm affiliated with the Computer Science department because I have this mixed background of computer science and music. A lot of the work that we do together is a group called UCSD MAKE, which is the Music and AI group. Next to it is the Center for Research in Entertainment Learning, CREL, which is hosted at the Qualcomm Institute. My work is primarily on AI and music, but as I said, also through CREL, I've been doing a lot with cross-cultural media communications, style, and in general, deep learning as a novel tool for manipulating text, manipulating images, and I think this is the wonderful opportunity to discuss how this all comes together in this human and AI-rich environment. I actually collaborated with AI to make this presentation because I didn't want it to be overly technical. After I created my bullet points and topics, and since I'm talking a lot with AI and ChatGPT, he also knows a lot about my other work, so it maintains its memory, which is amazing. So I said, well, how can I make this presentation more of musical, flowing, and entertaining? So I can tell you that these texts, what I'm going to read, except for a few edits maybe towards the end, were actually written by ChatGPT based on my bullet points. So I asked it to be more musical, more poetic. I will read you the poetry of AI about my presentation mixed with my slides. Here's our overture. It's a note held in the air, a single note trembling in space. It could be a saxophone, a brush stroke, or a line of text. What matters is that it waits for an answer. Improvisation begins with someone or something answers. Now the other voice is a machine. The duet feels unfamiliar, but the impulse is ancient. To call and respond, to listen and invent. The talk is about the duet, about how improvising with AI can become a way of composing new cultures. So here is an example of a performance we did in Bordeaux when I was staying there, where you can see the musician with that single note. It's a coincidence. I didn't hear that example. myself with one of the researchers running our improvisation system. What you can see in the background is another logical layer controlling how the machine responds to the musician. Let's start with this example, which is very contemporary, abstract, to give you that idea of call and response. And the response will be in the same sound as the musician. I'll have some more examples. So just a few things to note. Musician is interacting with the computer, but also signaling us to move on to the second section. The response was call and response. There was an imitation of his own performance, which was generated by the machine. The second voice, the other voices of the saxophone were actually generated through the AI element. Here's another example. Another French musician who is collaborating a lot with us, with the IRCAM team. And you can hear now, and then you'll hear another response, which is with slightly more metallic sounds, and that will be the computer. And maybe one more example in a different style, because these were more free improvisations. Oh, sorry. Now the piano was improvised. The piano was generated by a machine by looking up segments from a database of recordings, matching this to the musician's solo. It was planned, but not to the level of actually having a pre-recorded accompaniment, and that freedom of listening, understanding, and then deciding what to generate is actually something, a field of this music improvisation that we were exploring for, I would say, over 20 years now. Some of the AI techniques today are outdated, but they're very much close to the ideas of what we'll see next, which are these big language models and how we work with them. The overall architecture of such a system actually requires the system to listen, learn, and interact. But I would say having learning from a memory model, what we learn from, that whole data science aspect is very important, but that memory is actually learned. It's not a static memory. And that allows us to receive new signals, to listen to others, and then interact with the memory and with the human, with the musician. Movement one, the encyclopedic dream. In the 18th century, Dennis imagined the encyclopedia, a book that would gather all human knowledge and make it accessible to everyone. Each entry pointed to another. It was a knowledge as a web, not a hierarchy. That Diderot thought this would free the mind. 2.5 centuries later, we built his dream again, but now the encyclopedia writes back. A large language model, which is the basic for ChatGPT and a lot of the AI that we see today, is actually a self-rewriting encyclopedia. It reads every article ever written, then begins to answer in the same voice, linking, paraphrasing, remixing knowledge in real time. It's the encyclopedia with improvisation. So here's an illustration of the Diderot encyclopedia from the 1700s. And as a curiosity or historical fact, actually, in AD 77, in the Roman Empire, Pliny the Elder also wrote a huge volume of natural history, which was not exactly arranged as encyclopedia, but it had a lot of entries. And the reason I point to this was that even though it pretended to be scientific, it actually hallucinated. It talked about creatures like cephalus and monopod that never existed, but they found their entry because whoever wrote that was actually retelling the story of science at the beginning of the period. He basically took liberty of including things that he heard about, maybe imagined, but which were not true. So the encyclopedic dream continued. In sound, we have music transformer, we have diffusion models, and some of you might have used and heard about stable diffusion, text to image. So we have same in music and sound. So music transformers and diffusion models do the same. They start from noise, from pure noise, like static before the radio tune, and sculpt it into patterns, as if order were emerging from chaos in slow motion. Music has always been that, form drawn out of noise. These systems are not databases, they're generative instruments. They don't just store what we know, they explore how we might know them differently. One of our works, a multi-track music transformer with two of our students, Hao Dong and Ke Chen, who already graduated. One is a professor, one is a researcher in Adobe, and my colleagues, Julian and Taylor. This work demonstrates the use of a very similar transformer technology like the LLM for ChatGPT, which was used to train on a huge data set of music. The unique aspect of this transformer, which will be important for our discussion next, is that it actually uses multiple instruments. It looks at multiple tracks, which makes music so different from normal text, because you have parallel processes. You basically have people, voices interacting with each other. So this is a multidimensional transformer. Just to give a quick example of something that it generates as an orchestral piece. As we proceed with our story of improvisation and culture, the second movement that AI suggested is thinking through other minds. And I had this as bullet points, but he now formulated this into this poetic prose. Okay, so we talk now about culture in general. We want to move a little bit outside of the music domain. Cultural is not a monument. It's an improvisation across time. Every artist answers those who came before. Every phrase is both memory and variation. To live in a culture is to think through other minds. We guess what others expect, predict what they'll love or reject. That's mutual guessing is what makes society coherent. When we converse with AI, we practice this in a new key. We are not commanding, we are tuning. The system mirrors our patterns and misreads them. In its errors, we glimpse our own habits. So this is a slide from a work by a UK professor, Carl Friston, with his lab, and we have collaboration, joint student. Let's talk a little bit about what is actually that learning. And this applies to brain theory, but it also based very much on the same methods that the deep learning, the machine learning is working. So the idea in this case, you could think about the brain of a human, or you can think about an artificial brain if you wish. It interacts with the world, with external states. It creates a copy. It tries to mimic, predict, understand that world by building a model of the environment. It reaches out to the world, or the world reaches out to that brain through sensations. And that agent can actually either confirm if his sensations are correct or not by predicting the next thing that happens, or it can act to change the world. This step of what we call inference or variational inference, because what we do, we present a model which is a variation of the world, or active inference, where this inference actually changes the world, is a very interesting topic that connects cognitive science and brain theory with what computer science does. And for us as musicians, it provides a way to think about how we consume, produce, and perceive music. What is the meaning of making arts? Now, this is the learning from the world. But as we proceed to look at the world as data, we can think about music and that transformer, looking at a lot of music as some way of predicting the next steps. Transformers, language models work by predicting the continuation of sentences. This is a little animation from another work, The Music Transformer by Anna Huang, who is now in MIT, that shows how these memories are built and how they're used to predict the next one. The arches you see are the memories, the attention model, so-called, which is the basic of the transformer. Here it goes. You can see how for every new note, the model knows what is the past, how to look into that, and how to use to predict next notes. During learning, a point where the mind and the world were interacting by learning the world and possibly acting on the world. But now when we talk about society, and music is a social phenomena, in performance or in listening, okay, we have multiple minds, and these minds reflect each other as well. So when we try to think about the world, we also think about other people in that world, or people that we interact with, we perform with. And this phenomenon is called thinking through other minds. You try also to guess what other people are going to do, how they feel about this. And our common denominator is this world, which could be cultural conventions, heritage, things that we developed, or drive for novelty and exploration. As we move forward, we can think about voices as different minds. In fact, they are different minds, because polyphony is an interaction of different voices, different people. This might be the most technical slide, which I borrowed from other presentations of mine. Please ignore the math, but I would like to explain what we're trying to look at. We're trying to see how much communication is going on, or information between voices, using the same multi-track music transformer. So we study how one voice attunes to another, and then how the common thing, which could be culture and style, they set in some sense the relations, the harmony between these voices. As individual voices, that polyphony, that multiplication of voices can create new harmonies, new chords. Part of our work is not only to predict the future of this data, but also to predict the future of one voice, knowing that it's listening to another voice. If X is the machine and Y is the musician, the machine will generate something as a continuation of its own ideas, but it also has to take into account what the other musician is playing. And this whole idea brings us to our third movement, which is this market of ideas, the economy of imagination. A reference to historical interpretations from others who analyzed music, like Jacques Attali, in terms of political economy. Every new technology of sound has changed who controls meaning. The church music defined the ritual. Orchestras became the factories. When recording arrived, the music became a product. And when broadcasting came, the audiences became the mass. Now, with generative tools, the consumer becomes the producer. So the bolder part of this idea, actually, I asked ChatGPT to use specifically. I think this is a very important aspect that happens today. We have tools that lower the barrier to nothing. You can prompt your music production tools. We have companies that do this commercially now. And in a second, you get a song with lyrics, with voice, with full production. It's so easy. If you want to consume music, you can actually produce it yourself. Now the question becomes what it means to be consumer producer. You can have your own garden where you raise your vegetables. You can invest, you can trim, you can build this garden that you have. It doesn't have to be one idea that you throw at a time just to satisfy your immediate needs. What it means to be an intelligent or a demanding consumer will define what kind of a producer you are. In that sense, culture, like any ecosystem, thrives on curiosity, not consumption. It rewards those who venture off the main road, those willing to get lost and find something new. The new economy is not of money, but of care. What we chose to explore, the time we spend refining and listening, that's our new currency. Just a little illustration of the historical aspects. Music as a ritual actually had a lot of rules of what could be composed of what not. Dissonance, the triton, the double tone was forbidden. It had to be resolved. There are ideas, the stylistic idea of what message the music brings to social events was very much dictated. Once some notation appeared, the cantillation marks were made more precise, and then a notation appeared. That's what we see on the top right. Music suddenly became representation, became almost mathematical. You can now represent it, you can explore relations between voices, you can start writing polyphony, you can start writing harmony, you can start writing for multiple instruments. That's what allowed orchestras to appear. You could do this division of labor that created the concert halls, the operas. It became a product that people would consume, they would come to the shows. Then Edison invented his recording machine that made music the replication. You can now replicate music, you can spread it. It became a consumer object. And today we have these tools of production, the multi-track tools, or what we call DAWs, the digital audio workstations, that you can write music as notes, you can write music and you can record it as audio. And then we have the musical robots. This is Shimon the robot from Georgia Tech, who listens and performs. He also has these gestures in the camera that actually look at the musicians. So now we have this blended world where symbolic music, tools of production, multiple tracks, and artificial agent can all be part of music creation. So we come to this dynamic model of creativity where we have machine improvisation, where a machine knows style, it can model it, and you can input your ideas not necessarily as a musician, you can input it as a text. You have this meta creation need to understand what you actually want to ask the machine. And this creates an interaction between the human and the robot. And this is a creative interaction. Now, to make the machine be able to understand your meta creative specifications, your needs, your ideas, it actually dives deeper into our psychology, into linguistics, into the idea of what is metaphor, what is meta, and I will not go deeper into defining these terms, but actually blend cognitive science, even psychology, with linguistics as a way of thinking about how we actually chain our ideas and how we come up to a resolution, and how abstract experiences map to our everyday life, everyday feelings and sensations. Now, if you want to be personalized, there is an aspect of fine-tuning, and a lot of machine learning now is about fine-tuning, of trying to limit the scope of the ideas that the machine does, not only prevent it from hallucination, but also to make it more specific, more personal, something that what made ChatGPT become so popular and go from GPT, which is the generative pre-trained transformer, into ChatGPT, was actually fine-tuning this with human feedback. This kind of reinforcement learning with human feedback, what made suddenly ChatGPT become not just a text generation machine, something that is attuned and is able to communicate with us. Now, that machine can also have its own desires. So in the robotic world or in the game and reinforcement learning field, people talk about empowerment. The robot itself wants to have more power. It has to have more influence, position itself in a better way towards the other players. And that intrinsic motivation that we always ask, is the machine, can it be actually having its own intent, its own artistic drive? I think this is something we are very much interested in. It's a scary idea to let the machine have its own motivation. But as I'll show, that becomes a way to really become co-creative. You create your own kind of digital twin that understands, that tunes to you. Okay, he becomes your apprentice. And this is where the creation goes back to the human. So just a few more examples. One example, which was an early work on our diffusion models, which is the music latent diffusion model, explore the idea of text to music generation. But what we try to do, besides the fact that we have text prompts that describe the music and generate music, we also wanted to see, can it understand poetry? Can it go beyond specifying what kind of music we want to generate in musical terms? ChatGPT is able to address metaphors. If we take a poem like Maria Reed's End of Autumn and ask it to give us the musical impressions and translate it to prompts, this is something which amazingly is happening in the mind of the machine with this technology of able now to translate this to music. I hope you got the impression of how the music changed line by line. The machine itself generated the sound, but the translation had to go through this metaphorical layer. And some other experiments where we worked with sound poetry, Jaap Long, to create improvisations where his text was actually used as a basis to generate a lot of music materials. And then myself with George Block and myself were using our improvisation algorithms to interact with the poetry. So just as an example of what, let's say, the language models are capable of, taking the verses of Jaap Long, which are these kind of encrypted proposals, whatever that means for him, he knows how to perform it. And then ChatGPT interpreted this as mysterious and ethereal piece. The second verse was suggested to be electronic texture, and so on. By interacting with these ideas and the interpretations that technology gives us, we created this performance. Jaap would perform these sounds with George, controlling the improvisation software that we have, with set of musical examples which were generated by our latent model. Another example of interaction is using graphical scores. This is experimental musical practice. We took a treatise, 176 compositions by Cornel Cardew, a British composer, who wrote these graphical representations that humans are used to interpret. They're very ambiguous. It actually opens up the field of improvisation and interpretation to mixed state where you get that impression, you negotiate with your partners how you're going to interpret this, and then you perform the scores. Every performance, every ensemble does this in a different way. So we actually asked the machine to do the same. We asked it to look at segments of each score, create sound, and then render or improvise on these scores. Here is a chain of steps that uses AI to interpret the graphical score. It creates a set of suggestions for our music diffusion models. The user can also add its own prefixes, like what kind of music I want to have, sine wave, string orchestra, experimental, and then it keeps generating, but it also takes the past and has this loop and predicts itself while looking at changing descriptions of these prompts, with the user also providing some input. So I'll summarize. The finale. Beyond postmodernism, we are composing again. So in the last 100 years, art lived in taking apart, deconstructing, and exposing. Now AI gives us tool for composition, not naive reconstruction, but integration, the fusion of old motifs with new symphonies. AIism, it's a term that I suggested, and it's basically we living in AI-rich environment changes our culture. We have this AIism that could be a return from irony to harmony, a culture that can both critique and create, remember, and improvise. One of the important things, and I actually asked ChatGPT to mention that and integrate this, is a project that we have which we call polysemic AI. So what's polysemic AI? It's an AI that will not only give you one prompt, it will give you multiple ideas from multiple points of view, culturally, personally. It can represent low resource culture and hear silenced voices. It gives life to new harmony by negotiating dissonant perspectives. There's an illustration from a technical paper that talks about AI agents, how the user interacts with them, how they have a database that it can actually use with its language model to create new responses. This cycle working together with the user is a world where I think the integration of AI and the human can become very exciting. Integration of AI with multiple humans together, I think, is a huge potential. So what we need is a generative model, which we already have. We keep improving them. It actually learns the probability distribution. It predicts the messages, in our case, in musical data. It creates novelty by random sampling from the model. It also allows interactivity, where one influences the output by querying, prompting that model. It's responsive to context and following instructions. It can be cross-model, which means it can work with text, images, can respond to them, can find relations between these things. It has the semantic and metaphorical abilities or mappings. It's agentic in the sense that the human and machine or agent-to-agent interaction has to be understood much better. It has this pragmatic aspect, emergent communications between machine and a human, multiple humans with a machine, where we actually create new languages. We try to understand each other. That's the concept of emergent communications, which is actually a field of research in natural language processing as well. The novelty comes from anticipation supply. So some of our work from the underlying theoretical aspect of information theory that we applied, that we call it music information dynamics, the idea of this transfer entropy, the relations between how information is transferred between agents in this multi-track environment, and how make the agent have its own intent, its own empowerment. I think these are the next steps in AI. So the postlude, and I would say here AI kind of surprised me, because he said, maybe I a little bit shortened the slides, because he said, here's a new scale. He wanted to have 7 points because we have 7 notes in the scale. So he said, here's the new tonality for AI. Here are 7 points. We start with memory. We start with cultural heritage, the resonance of all what has been played before. Then it comes to this knowledge construction, markets of meaning. By approving attention to what happened before, we decide what is going to be replayed. What drives it is motivation, this empowerment, the curiosity that pushes beyond repetition. The creativity is really the essential next step, which is the impulse to modulate, to create something new. So here we have basically a combination. The first 3 steps is really the cultural heritage, the construction, the production of knowledge, and creativity. Now, when we think about this as something that lives inside the world, inside the society, we come to the point of empowerment. The human and machine trade motives inspire each other, but then the human and the machine need to have their own authenticity, because this is one of the basic critiques. These AI models very often create cliches. They just replicate things and recombine them into patterns which are the most expected. But now you want to have your voice, your authentic, novel creation to be born. It is born from effort, time, and care. Like in that garden where you can now grow your own vegetables, but you want to spend time, you want to invest, and you want to maybe even create new types of plants. It takes time. Musicians who work with AI, even with commercial software, don't just prompt. They can spend weeks and weeks refining things that machine generates for them, actually until the point that they actually fine-tune it to their own creative intent, to their own satisfaction. Now, to have this exist in the cultural setting, we need harmony in dissonance. We have the coexistence of many interpretations in one chord. The cadence is this responsibility, which is the topic of the next talk in this event. It's the cadence that resolves the piece, balancing safety with surprise, alignment with freedom. So I think at this point, I will end my presentation, and thank you for having the opportunity to present these ideas as an opening for this wonderful discussion.
Perfect. Thank you